Hello and welcome to PCB Chat, where we talk with experts across the printed circuit design, manufacturing, and electronic supply chain fields. I'm Mike Buteau, president of the PCEA. It goes without saying that finding talent is a big deal in electronics design and manufacturing. My guest today is John Watson. John's day job is customer success manager at Altium, but we've invited him on to talk about design engineering training. Specifically, John is teaching a course, well, two actually, on printed circuit design at the college level. Hi, John, and welcome to PCB Chat.
Thank you very much, Mike. Thank you for having me.
There's a lot I want to go through today. You're teaching at Palomar College, which is in San Diego County.
San Marcos, California, to be exact.
San Marcos. Very good. Thank you. So let's talk about the class itself, and then we'll get into what initiated it.
Okay.
As I understand it, there are two segments, printed circuit board design and advanced printed circuit board design.
That's correct.
Give us a sense of what you cover in those courses.
First off, let me tell you what my objectives are. That kind of what drives the curriculum a lot. First off, my objective is in the basics class, is to take brand new designers. There's no background that they are required to have or any prerequisites or anything like that. These are brand new designers that I bring in. So that's kind of where I start things with the basics class is step one, sort of. My main objective there is to walk them through the entire PCB design process. Now, I have, in the basics class, I have 16 weeks to do that. It's a really good chunk of time, really. I conduct class twice a week. It is an evening class. It is an online class, which makes it convenient for a lot of my students. Which actually has now opened up this entire class nationally. I actually have students outside of the general San Diego area, and it really makes it convenient. So in this class, what we do is we focus on the four stages of the PCB. Those four stages that we've divided this up into are, number one, the libraries. So we will talk about the library structure, the component structure, different things like that. Those things become very important as we go through then the design process, as we see why was it so important that we put certain things in our components at the beginning there, things like that. And the second stage then is our schematic. So from here, it's a very linear process that we walk the students through to create their own and usually their first PCB design. They go through the schematic, then we push that into the PCB, and then we go into the documentation stage where we output everything, our Gerber packages, our fab drawings, our assembly drawing, and so on. That's our main focus on that class, is that we get them through that process from start to finish. Now, that's like I said, it's a very linear process. So we kind of build on what we did the previous week, and we kind of say, okay, now that you've done this, you now can do this next step and next step. So in the advanced class, which is another 16 weeks, we kind of pick it up from there. We pick it up from where we created our document package, and then we actually go into the fab and assembly process. I think this is an area that a lot of times is missed by a lot of designers. I work with a lot of fabricators, assemblers in the area here, and I've asked them, I said, how many PCB designers actually come and visit a fab house? It's actually very, very low. And I would encourage you, even if you're a PCB designer today, visit a fab house. Understand how this all comes together, and you'll have a much better understanding of printed circuit board design. It's really an interesting concept and process that they go through. But let me go back one step here. In our basics class, we actually do a printed circuit board from the Mars rover. So this is a controller board from the Mars rover that we give to the students, and that's their PCB project that they're working on throughout that semester. In the advanced class, we then look at 3 PCB designs. So we focus more on the PCB side of this and the layout side, because what we developed there is a much deeper dive into the PCB process. All right. So in the first, we divided it up into 4 stages. In the first stage, we talk about the fab and assembly process. We actually visit a fab house. We see the assembly process. We see the machines and that. We see the steps that are taken by the fab house to take our data and create the board then and actually bring back to us a completed design. So it's really exciting process when you look at it in that whole kind of those steps. The second stage of the advanced class, we go into rigid flex design. This is really an amazing area. I think it's one of the faster growing areas of PCB design, especially with the ontake of wearable medical devices, things like this. They really kind of have driven that entire industry. So one of the things I concentrate on for 4 weeks is rigid flex design, and it's really exciting to watch the students do that PCB. We then go into advanced PCB design. So now they're working more on they actually do a BGA design, a rather big one. So this now involves all those different important physics of electronics, we'll call it, of the advanced, the EMC, EMI. We talk about length tuning, all those great things, skin effects, and we talk more about why things happen in the PCB in the way they do. All right, so let me explain that. In the basics class, I'm more concerned about them connecting the dots. All right, really. I'm like, okay, here, let's solve the puzzle that you have in front of you. Now, in the advanced class, I kind of take that now and I say, okay, now let's look deeper into why a trace will be this length, or why we need to have protection for our EMC, EMI. So I go a lot into the physics of a trace and the physics of the printed circuit board itself to understand why certain things are done. So now they have a much broader picture of exactly why they should do things the way they should. The last section of the advanced class, we take the 3 PCBs that we've done in this class and we put them together. And we actually build a system design from there. So now we're talking about system configuration, system design, harness designing, things like this. We also get into more of the MCAD collaboration side, where we're actually now looking at a role of the entire team, of who is involved with who, of what deliverables, we'll say. And they actually now will kind of work together as a team on that final project. So if you look at this as a whole between the basic and the advanced, I have 32 weeks, which I will tell you is not enough. it's not enough. I was recently talking to some a professor and department heads of major universities in March. And I was asking, they were talking to me about the program, and they asked me, how long do you teach just PCB design? I said 32 weeks, and they go, wow, I do 6 weeks. I go, what do you teach in 6 weeks? I mean, it's like I barely touch this. I barely scratch the surface. So, but this is a phenomenal program. It's a just kind of give you some history. Palomar College, this is a program that's been going since 1995.
Bill Brooks.
Bill Brooks was my instructor at Palomar College. But before Bill Brooks, there was a young gentleman by the name of Mike Creedon, who I
know Mike
started it. And he actually spearheaded this in this area. And it's been going for that nearly 30, 40 years now. So it's really exciting to be a part of this. I am now the next person, the next professor that has filled the ranks here. And I'm really honored to be doing this. It's a really phenomenal the legacy, the history, the heritage that we have here on this class is just amazing. I am real honored to be here.
John, do you get into things like impedance control, EMC, transmission lines, things like that?
Yes, yes, absolutely. And we tie this into the physics of it. So we say, okay, now if you have a trace of this length, what are we talking about here? Well, because of the copper formation and because of the atoms and because of the free electrons sitting out there that basically gets kicked around by everybody, right? We could now start developing from those basic physics principles, some other things. And that's how I deal with this, is that I go, okay, so if this is true, then let's look at this, how this affects then our layout. All right, so then if we have a trace of this length, we can determine there's a set impedance. We can then set, so we talk a lot about in single line impedance. We also talk about differentials, why and where they're used. We also then get into length tuning, and then we get more into the energy of the trace when we talk about EMC, EMI. Now, how do we control this sort of thing? So we look at the PCB in a really, really deep detail in that advanced or in the advanced section of the class, where we look at it and we say, okay, there are some things here we like, and we like to control. We use these principles. That's the way I would say it, to benefit our design. And let me give you an example. When we're talking about differential pairs, we actually love crosstalk. All right, we want crosstalk, but yet when we're talking about, let's say, a high speed design, no, we don't want that. We want to be able to protect our circuits and things like that. So having the students understand why certain things are used and how they are used, they actually begin to see a PCB in a different light. They don't see it as just solving the puzzle and making the connections. They look at it as saying, as an engineering, almost a mechanical item. It's actually, with the development of the PCB design, it's actually understanding the physics of it. All right. And that's exactly what I try to bring into the students. So it's really an interesting area.
John, you mentioned that the class is taught online. Is that a concession to COVID that's just carried over?
Yes, yeah, exactly. And it's really been beneficial for us. I've actually enjoyed teaching it online rather than in a classroom, because what is happening is I can actually have a student who, let's say, has a question actually share his screen, and we can walk through it as a class watching his screen, which really makes it beneficial for everybody. Otherwise, if I was in a classroom setting, I'd have everyone gathered around his computer and peeking over each other's corner, other shoulders and everything else. In an online class, it's really, really beneficial. I can actually have him share his screen. We can walk through the problem, and my students have really kind of enjoyed that aspect of it.
And how many nights a week do you teach?
2 nights a week. Right now, my class is scheduled to start on August 22nd, the fall semester here. We are doing an evening class from on Tuesday and Thursday for 3 hours each.
Now, you mentioned that you do a visit to a fab shop, but if this is online, how do you replicate that?
That is the one time that we will come together as a class. Is that tour of the Fab House? We will bring everybody together, and we actually then tour it. It's usually the first time I meet my class face to face.
And if the students aren't located, within a reasonable drive, do they just sit that one out, or is there some other way that you try to convey that information?
I actually have I can't record the tour of the Fab House. This is an ITAR compliant facility. But what I do have other tours that processes and things like that I have of videos of the process. So I do have them look at those. And one of the other things I would add is that with my out of state students, I actually go visit them at some point. This is something that I've got into the habit of, is that I like to meet my students face to face. I want to find out why they are taking this course, and that's usually a question I ask them very first night. I ask them, I want you to take a piece of paper and I want you to write why you're doing this. I find that as such a great motivator for them later on, because I tell them, I said, this is not going to be an easy class. This is not a skate class. This is going to be very difficult. If you've never done this before, you're going to find this, frustrating sometimes. You're going to pull your hair out and all this. But I want you to write down at the beginning why you're doing this. Then when you get into those situations where you are frustrated, pull that sheet of paper out, reread it, and refocus yourself on why you're doing this. And that is so important to understand when you're, especially in, I mean, there's a principle that we want to try to do even in what careers we have now. I do it in my career, is to understand why I'm doing something, not just doing, looking at what I'm doing, right? So it's a really important principle.
You're taking homeschooling really literally there.
Oh yeah, yeah, exactly.
It sounds almost like like Mr. Hand and Jeff Spicoli in Fast Times at Ridgemont
Yeah,
High, right? Showing up at the at the student's
yeah, exactly.
house.
One of the things that I have come into this in through the industry. I'm not a professor. I didn't just go to school and say, yeah, I'm going to be a teacher. It was sort of where as a person who's been in the industry for 43 years now in electronics, and 23 of those in PCB design, it was something that I love doing, first off, but I bring a lot of this experience into my classroom as real world experience. I don't just say, here, read this chapter and take a quiz or do this is. I bring a lot of real world exercises and experience into this, to where I run my class the way I would run a company. And I'll give you a great example. I will have my students doing a PCB design or doing their lab, working on their designs, and all of a sudden I'll just say, look, we just got a phone call from sales department saying we got to cut $50 out of our BOM. What do you do? And you hear the shrieks going up through the class. You know what? I go, this is real. This is what happens. All right. It's not a PCB design, as much as we would love it to happen. Right? Is I love to start it, and everybody leaves me alone, and nothing happens, and there's no challenges and everything else, and I just work through this whole process, and it comes out the other side, and it goes into fab, and it's all perfect and everything. And
Yeah,
it
good
doesn't
luck.
happen that way, right? There are people. I remember the old video game years ago called Pitfall,
Oh yeah.
the old Atari game, right? I used to play it. Now I'm aging myself, right? But it used to be where you're running through this jungle, and the whole jungle would open up, and you'd fall into this pit, right? And that's PCB design. That's how I describe this to my students. That's PCB design. It is like you're running a gauntlet of issues and problems, and all this and that. You try to keep control of it, but it's how you control that, and what affects your design. And this is how I teach it. Is, okay, now you've got this issue. Now where do we go? What's our first steps? What's our next steps? And so on and so on. And one of the traits I give to my students is, very first night I tell them, you will be successful in this course if you learn to eat the elephant. Learn to eat the elephant. Take it one step at a time, one bite at a time. Don't get frustrated by it, and you'll get through this. All right. It's all done by one step at a time. Understand what affects other things and things like that. So it's really kind of interesting. I really have a mixture of students, by the way, in my class. I have double E's, which are actually training for a double E degree. There's that level in the college system there. There's also brand new PCB designers that are looking for career changes or things like this. Uh, that's probably one of the most interesting areas, because you would think that, well, okay, well, double E, right? They should have this all down. Well, I actually find that the double E's have more of a problem with PCB design that I've seen.
Why is that?
I think it's because they get too much into the details of it, and they get lose their focus on the solution. That's the best way I can describe this. Is they'll lay down a trace, for example, and they'll say, "Was that correct?" Well, it's is it the better question is it a solution? I give each one of them the same schematic when they start, but yet I tell them every one of your PCBs are going to be different, and that's what's unique about PCB design. Is this is the artistic side of all this. This is where your kind of individuality comes out in the PCB design. And a lot of times I find that double E's have just kind of a little bit of the mental processing that they do, that they kind of have to look at it in a much a deeper sense. And I've actually seen in my career that some of the best PCB designers are artists. They come from that field. Bill Brooks, as you mentioned earlier, is what now? He's a world renowned sculptor, beautiful sculptor. And I think of other people that Susie Webb, who we know, right? A landscape artist, different things. So it's very easy connection between the artistic side of the PCB design and and the artist, we'll say. And you can't teach that side of it. It's something that they have to see for themselves. It's where they see a solution, they see the PCB, and they kind of visualize it of okay, I see how this can come together, and the puzzle, you know.
Yeah, I do think that, understanding or thinking in three dimensions helps a lot. Another colleague had suggested that the future of PCB design is playing Minecraft right now, and I don't think she's wrong. I think that
Yeah,
that it teaches you to think in three dimensions and just not think of everything as a flat object. And particularly now, the way that designs are going, and there's so much connected to that. You have to think of
right.
the chip and the board almost as a single object. Being able to uh, consider more than just this trait on this plane is really important.
Right. Yeah, and we definitely get into that with the advanced classes when we start developing our layer stacks. And now, the basics class is a 4-layer board, but when we get into the advanced, now we're talking about 8 and 10 layer, because we're talking about a rather big BGA, and they have to kind of think now, how do I formulate, put this puzzle together in much more of a broader sense. Um, but yeah, I I have a lot of. It's interesting when I take my students through the process, especially when we make the jump from the schematic to the PCB. I don't tell them what's going to happen here. I mean, it's like, okay, folks, we're ready to jump over from our schematic into our PCB. Go ahead, and here's your process, and we're going to push this. And now I just let them kind of go through those steps. And what happens is I just kind of take a step back, and I watch this, and they push their schematics in their PCB, and all of a sudden it's like, holy smokes, what happened? What's going on? It's like, right? It's like they, with all the connections and all the components and the rat's nest going everywhere and everything, right? And I kind of referred this to my Mr. Bill moment for my students. Right? It's like, it's for the younger students in my class. It's like, well, who's Mr. Bill, right? But it's a really kind of a great, interesting process. I love the fact that we can take these students and bring them through this process. I I really think that this our industry needs this. And that's really what kind of drives me. I've noticed for close to 10, at least 10 years now, there is a downturn of available talent in our industry. I get calls every week from companies saying, "Well, are you available for work? We have, contracts. We got this going on." And there is a real lack of talent in our industry. And this has been a growing trend for at least 10 years that I can see. Where, I mean, as a matter of fact, PCA does their yearly survey of PCB designers, and they ask them the question, do you intend to retire in the next 12 months? Right? The infamous question, I call it. Those percentages have been well into the 60s. I mean, high 50s or low 60s for some time now, and that is an alarming percentage. And when you look at it, I tell companies. I actually had a meeting with SMTA yesterday. I did a presentation for the West Coast. And I asked the audience, I said, has anyone else heard the massive sucking sound coming from companies? It's the talent that's walking out the front door. And that's exactly what it is. It's those experienced designers that have that walk out with their all the years of experience, their know-how, their knowledge, all that's walking out the front door every year at a very significant percentage rate. And it's something that I've seen for some time. So when I had the opportunity to step in and actually reverse that trend, I grabbed the opportunity. Palomar College is one of the only colleges in the nation that offers PCB design at this level. 32 weeks. Most of the universities, things like that, only offer, at most I've heard, is 8 weeks of PCB design. So it's one of those areas that we can actually take advantage of, and we're working now to work with companies, and it's really a broad kind of vision that I have, the college has here, of working with companies, saying, okay, if you are needing individuals, internships, we would love to have you open up opportunities for our graduates and our individuals. Or if you have people that need training, please let us know. We're glad to train them. And that's I have several students that have recently gone through my advanced class that were actually referred to me from the company. So now they go back to their company that they work for, and now they're at a better position to work in that whatever their area they're working in.
John, how many students take the basics class and then don't take the advanced class?
My percentage is about 70% from the basics to advanced. So there is a drop. Now, one of the things that I'm working on is to open up the advanced class to those who are experienced designers. That's something I'm looking at, and it's been requested a lot by individuals. Is like, okay, I know PCB design, and I would like to take the advanced class. So we do have the 226 class as a prerequisite. But under the discretion of the professor, they can accept students into the advanced class. So that's what I'm going to be looking at for my spring semester in 2024. It starts in January, is bringing students in that have already been working in the PCB design, something like that. And that will be that will actually increase that percentage a lot, I think.
So, and just to clarify, the 226 class is the basics course.
Yes.
Yeah. So here's a key question. Do you teach hand routing or auto routing?
I do not teach auto routing.
Why not?
First off, I don't see auto routing as a popular thing in PCB design. If you ask most designers, this is a great survey question. I would love to ask kind of an industry wide how many auto route PCBs, and you'll find that the percentage is very, very low. And I kind of give it to my student, and that is a question that comes up: is that if someone is familiar with PCB design, they say, "Well, can I auto route my board?" Well, I would prefer you not to. The reason is I want you to learn this process. My my goal here is to teach the students critical thinking, solving the puzzle. And when you just go push the button and come back, go get your coffee, come back, and let it do what it's doing. There's a couple problems there. Number one is you're not involved in the PCB design process. You've kind of stepped away. You've let it kind of run its course through the AI of the program. Now, I find from what I've seen is I find that this is not popular in our industry because it pulls you out. That very reason, it pulls you out of the design process. I find that people do PCB design because it's solving the puzzle. It's the whole creative process of this is they want to be a part of that. And auto routing completely takes you out of that. So no, I don't teach auto routing, and I teach them hand routing of boards. Now I will bring in some of the active routing or the intermediate routing techniques that you're not just laying a trace down from point A to point B. There's some tricks on the tools themselves that are not auto routing, but will help you to improve your routing techniques. So, and it still keeps you in full control of the route process.
So that's fair. The Mars rover board, is that the one that was built at Pioneer Circuits?
Yes.
Did you have a hand in designing?
No, no.
Okay.
So,
Um, so, what extent have you been able to modify or add to the curriculum? Since you inherited something that was already there, have you been able to put your own personal stamp on it?
oh yeah. Matter of fact, my curriculum is very fluid. Being that I will go through a semester of both classes, and I will then, in the fact that I have companies that are first waiting for students who are want to that get through this course. Now, I'll tell a story about a young gentleman that actually just did my course, but I also talk to these companies about what they need, what technologies they're now bringing in and developing. And from that, I actually massage my curriculum each year to kind of focus on what companies are looking for in the sense of these special technologies. As we know, right, it's constantly changing in our industry. I think we're seeing some greatest innovations that we've ever seen in our industry right now is that things are really really fantastic. I mean, unbelievable innovations. So I have to do this with my course is I have to constantly keep looking at it and say, okay, what do I change? What do I keep improving on? And that's a major part of what I do, especially outside of class. Now, I have an individual that who came into my basics class, and he was a janitor. He was like, "Yeah, I just want a career change. It seems an interesting area to be in, and I want to be a part of it." And he went through the basics class and the advanced class. Never had done a PCB design before. Now he works for a company up in Carlsbad as their junior PCB designer. Very happy gentleman. Yeah, and this is what I kind of focus on is that I develop my curriculum from the companies. I then work with those companies to say, here is an individual that has learned what you want him to learn, give him an opportunity and open up an internship or a job or whatever it is.
So I love that about community colleges, right? I mean, I think about four-year institutions, and usually one of the metrics is X percentage of our graduates had a job within 6 months, and that's great. Okay, that's important. It's a huge investment of time and money and all the rest of it, and so you want to walk out of there being employed. But community college is all about being employed,
Yeah.
learning how to do something and put it into practice. And if I look at Zippia, the most common academic background for PCB designers in the US today is an associate's degree.
Yeah.
So Palomar is really in the sweet spot in that regard.
Oh, yeah,
Um,
absolutely.
I want to talk a little bit more about what Palomar is doing here because I think it's important. I mean, they're really punching above their weight when it comes to design. And there's also classes on geometric tolerancing and dimensioning.
Yeah.
There's multiple classes on 3D design using SolidWorks. So whether you're into electrical or mechanical, it seems like there's something for everyone.
Oh, yeah, absolutely. And I was that is something that we are definitely known for at Palomar College. If you look at the community college program, I'm just looking at taking a snapshot right now of San Diego, for example. You will have specialty areas of each of the community colleges that exist here. Palomar College is quickly becoming known for its engineering side of this. If you want to learn engineering, Palomar College is your place to go. And yes, we have programs that are not just for the development, but now also this manufacturing side. We're now looking at the CNC milling side and the mechanical side, and all these other disciplines in the design process, which is really really phenomenal. I'm looking forward to the time though that I put this out to the college is saying we as a college could develop a kind of a system or a kind of college project, having each of our disciplines that we were kind of all working in our own areas, is saying we could come together and work as a college towards a single project of some kind that would involve all these different disciplines, and that's what we're looking at doing in the future.
To that extent, Lorain Community College in Ohio offers an SMT or an advanced assembly program for electronics.
Mm-hmm.
And they actually have built it to the point now where it's a bachelor's degree offered from a community college.
Right.
The program is tied into local OEMs and assemblers who will effectively sponsor future employees, right? They're not their own employees, but they will say, hey, look, we have a need for X number of people. So if you graduate 5 people in the next 3 years, we guarantee that we'll have a job for those folks.
Right.
It's a very interesting model, but it does kind of have a hard cap insofar as the number of students that are available to go through the program at any given time.
Mm-hmm.
With the Palomar design courses, especially being online, it's, the opportunities are much broader, and because you don't have the same kind of equipment constraints, right? You don't
Right.
need an SMT line,
Right.
in your bedroom in order to learn this. It's a much broader potential reach.
Yeah.
Do you actually have a cap on the number of students? Because obviously there's a point at which there's going to be diminishing returns. If there's 50 people in the class, you're not going to be able to do everything you can if there's 25.
Right, exactly. We are capped for a class at 22. I usually shoot for 25. There will be a few dropouts at the very beginning. But each class can have that, let's say, 25 number. So what if, for example, my first class fills up and I have enough people on a waiting list, I could then approach a college and say we'd like to conduct a second class. All right, so that could actually be done on 2 alternate nights, of the week. So that is something that is there as an option. I just find it interesting. Well, I will tell you some history that last year at this time, they were actually looking at canceling this class entirely as a college. I spoke to the dean of the college and told them that would be a very bad mistake because we are in an industry that needs these individuals. The need is out there, so I actually took up the challenge of filling this class, and it's one of my major undertakings is not just to fill this class, but also fill the waiting list because I see it as look, if we can't find 25 people nationally, okay, who would like to learn PCB design, then we're in trouble. All right, really, we're in trouble. And this is something that I that's what exactly I told the dean. I said, this is the need is out there. It's just a matter of getting the word out there that this is available to individuals that you can do this. You don't, and you don't need to have a prerequisite. You don't have to have a double E. You don't have to have this special training or anything else like that. I've seen individuals come from every area of life into this industry, and I personally came up the route of an electronic technician. That was my path that I took, but you can do any path that you wish, and that's what's amazing about this.
Yeah, the unemployment rate among PCB designers in the US is less than 2%.
Yeah.
If you can do PCB design, you will be hired.
Oh
You
yeah.
will have a job. So if I go back to Lorraine Community College for a moment, one of the things that their director told me was that they've offered to license the program to other junior colleges around the country and
Mm-hmm.
have gotten no interest. Has Palomar talked with other community colleges, or even for that matter, other four-year institutions about packaging up this coursework and offering it in some way, shape, or form?
Yes, yes. We are looking at getting this course certified by the state right now, and we are then anybody in the community college system in California, at least to start, they will be able to take this course and get credit for their own college. So we're in that process right now of getting this statewide. And to have this available to other students because I get students from those colleges right now that are attending this for the sake of learning the knowledge and learning it, but not getting college credit. So they're at least they're doing that, and that's what the steps they're taking. But we would like to be able to have them get college credit. The steps I need to go through with that is to get my course certified, signed off by the state community college system, and then it will be accepted. And because it's online, it makes it really convenient. Anybody anywhere in California will be able to take this and get college credit. But right now, it's open up to anybody who would like to learn this subject.
Well, John, your passion for this really comes through, and I applaud your efforts here. The Palomar website, for folks who are interested, is Palomar, PALOMAR.edu. And John, can folks contact you directly if they want to learn more?
Yes, please. You can reach me at john.watson@altium.com or jwatson@palomar.edu. And I will also put out my personal phone number, 619-886-8860. I would glad to talk to you about getting you enrolled in the class. The class is open for enrollment now. It begins in August 22nd. I am counting down that day. And I can tell you this class will fill up. So if you're interested, you need to take the steps today to get involved, get signed up and enrolled, and get your name into this class. It will fill up quickly.
And I want to add that John will be among the panelists for the Next Generation Engineers panel at PCB West this year. The conference takes place September 19th to 22nd at the Santa Clara, California Convention Center, and the panel takes place on September 20th, the same day as the exhibition, and is free to attend. You may register at pcbwest.com. John, I want to thank you so much for coming on PCB Chat today. This has been a great conversation. I've learned a lot.
Thank you very much, Mike, for having me. It's been a pleasure.
For PCB Chat, this is Mike Butow. Have a nice day.